This is Unit 3, Lesson 2, Part 2. So this time we're going to be graphing absolute value inequalities using a table. So I know it says it right below, but we'll add the topic on here. Again, using a table. Sorry for the super long title again. But in the future, we'll be graphing without a table, so I want to make sure you know which one we're talking about. So graphing absolute value inequalities using a table. This is just one page. It'll be a much shorter video than the last one, so hopefully that'll make up for it. So we have this step-by-step. We're going to launch right into doing number 1 by following this step-by-step. So number 1 says create a table of values. Now this step is done the exact same way as part 1 of this lesson was done. So we start, they have a little reminder here, recall the vertex should be in the middle row. So the way that we do that is by taking the expression from the inside of the absolute values, which here would be the x plus 1, and setting that expression equal to 0. So you do that each time to make sure that the vertex ends up in the middle of your table, which puts it in the middle of your graph. Subtract 1 from both sides, so we know that an x value of -1 is going to be dead center on our table. From that point on, we go up to 0, 1, and 2, and we go down, -2, -3, -4. So we've got the x coordinates set up on our table. Now they get plugged in, and you make the table just using this right-hand side. Don't worry about the inequality just yet. So we're going to sub in the -4. -4 plus 1 is -3. Absolute value is +3. Then the -3 plus 1 is -2. Absolute value is 2. Then the -2 plus 1 is -1. Absolute value is +1. Then the -1 plus 1 is 0. So of course that absolute value is 0. Then the 0 plus 1 is 1. So these are now coming out to be positive values. So if it comes out as 1, the absolute value is just 1. Then 1 plus 1 is 2, and 2 plus 1 is 3. So that's our table. So that's looking back at our step-by-step. That was the first thing that we needed to do. So then step 2 says graph. Now, again, this part, basically the exact same as what we were doing yesterday. So I have 7 points. I'm going to plot them on my grid. So -4, 3 starts 1, 2, 3, 4, and up 3 right here. -3, 2. -2, 1, -1, 0 is right here on the x-axis, and that was my vertex, so that should be my turning point, so now I should be going back in the other direction. 0, 1 would be right here on the y-axis, 1, 2, and my final point, 2, 3. So now do not connect the dots. This is where we start to get different from what we were doing yesterday. So now look here, it says use a dashed line if it's just a less than or just a greater than, and a solid line if it's a less than or equal to or greater than or equal to. So look back at our problem, we've got just a less than. If it does not have the or equal to, then you should be doing a dashed line. So connect the dots, but do it with this little dotted line like this. Okay, so we've got a dashed line, and that basically just means the line is not actually included in our solution set. So that was step 2. The only difference here is that because I had just a less than, I did a dashed line. Step 3, now you do one of the other for step 3. You either shade above the line if you have one of the greater than symbols, or you shade below the line if you have one of the less than symbols. So we have one of the less than symbols. So to make sure you're clear on what it means to be either above or below, I like to look at the vertex. And less than that vertex would take us down to this point right here. So it's this region is what we mean by below the graph. Because sometimes it's kind of like inside the V or outside the V, depends on which direction it's pointing. So less than means we go underneath and then you just shade. So if you want to use, pencil, crayons, highlighters, whatever feels right to you. So this is our solution set. So basically what this means is that if I were to pick any point in this ordered, like in this whole shaded region right here, any ordered pair, and sub it in here, it would make that inequality true. If I plugged anything in the non-shaded region, it would make my inequality false. So that's what an inequality looks like for absolute values. Let's try another one. We'll do number 2. Number 2, we're going to start with the vertex so I can set up my table of values. So I take just the part from inside the absolute values and set it equal to 0. add 5 to both sides. So 5 ends up being the center of my table, and then I can go from there. So I go up, 6, 7, 8, go down, 4, 3, 2. So I can plug my values in. So 2 minus 5 is negative 3. Absolute value is 3. Minus 2 would be 1. Then 3 minus 5 is a negative 2. Absolute value is 2. Minus 2 is 0. 4 minus 5 is negative 1. Absolute value is 1. Minus 2 would be a negative 1. 5 minus 5 is 0. Minus 2 is negative 2. That's my vertex, so now I should turn around. 6 minus 5 is 1. Minus 2 is negative 1. 7 minus 5 is 2. Minus 2 is 0. And 8 minus 5 is 3. Minus 2 is 1. So 7 points to plot. Go ahead and do that. 2, 1 puts us right here. 3, 0 right here on the axis. 4, negative 1. 5, negative 2. So we just climb down until we hit that vertex, and then it turns around and goes back up. 6, negative 1. 7, 0 back on the axis, and 8, 1. So stop there. Look back at the inequality. Step 2 says because this has the or equal to, that this will be a solid line. So solid line for that V-shaped curve. And then this is a greater than. So step 3 says shade above the line. So kind of look at where the vertex is. If you go up from there, that puts us like in the inside of the V-shape. So kind of like above it and inside of it. So that is this region right here is what you will end up shading for number 2. So I want to make sure we include every combination. Like I want to see less than, greater than, you know, all the different combinations here. So the next one we're going to look at is number 4. We've got a less than or equal to with a negative sign out front. So let's talk through that one. So make our table first by figuring out where it's supposed to be centered. So you take the 2x from in here and set it equal to 0. Divide both sides by 2, and that's still 0. So this one's going to be centered at 0, kind of like our original graph was. So from 0 we go up, and we go down. Then plug in there. So this one's going to have a few steps. So take this value and multiply it by negative 2. So that comes out to be negative 6. Absolute value is positive 6, but then this takes it back to a negative 6. Okay, so then you add 3, and that would be a negative 3. So a lot of steps with this one, a lot of kind of mental steps to keep straight. So you can always feel free to use a calculator if the mental steps are getting to be too much. All right, so negative 2 times 2 is negative 4. Absolute value is positive 4. But then this makes it negative again. And remember, they don't cancel out. So I have negative 4 plus 3, which would be a negative 1. Then negative 1 times 2 is negative 2. Absolute value makes it positive, but then this makes it negative. So I have a negative 2 plus 3, which is 1. Then the 0 is a little easier at least. This will be 0, and then plus 3 is 3. Next is the 1. 2 times 1 is 2. Negative 2 plus 3 is 1. Then the 2 times 2 is 4, so this is negative 4 plus 3 is negative 1. And finally, 2 times 3 is 6. Negative 6 plus 3 would be a negative 3. So I have 7 values to plot, just like always. So let's start with negative 3, negative 3. Be right here. Negative 2, negative 1. So this one's going to be a little bit steeper, and that's because of the 2 that we have right here. Anytime we have a 2 out front, it's going to end up being steeper than the ones that don't have 2s, like number 1 and 2 don't. Negative 1, 1. 0, 3 is right here on the y-axis. See how much steeper this one's going to be? And that's the vertex, so now it's going to go back in the other direction. And remember, it's upside down because of this negative sign here. 1, 1. Negative, or I'm sorry, 2, negative 1. And 3, negative 3. So it's steeper, it's upside down. The steepness is from the 2. The upside downness is from the negative 1. And then the fact that it moves up to 3 for its vertex is this 3 right here. So now look at the inequality. Less than or equal to means I'm going to have a solid line connecting all these dots. And the less than means shade below the line. So here's the vertex. Go down below the line would put you kind of on the inside. Underneath, but this time you're kind of inside of that absolute value shape. So this one looks like this. All right, let's look at one more. number 5. Okay, so we're going to set up our table. Start by taking the expression from the inside and setting that equal to 0. This one's actually a 2-step. Add the 12 to both sides, and then divide both sides by 2. So we end up with x equals 6. That's the value that goes here. From there, I can go up, go down, and then start plugging those x values into the equation. So when I plug in 3, 2 times 3 is 6, minus 12 is negative 6. Absolute value is 6, and finally minus 7 is a negative 1. Next, 4. 2 times 4 is 8, minus 12 is negative 4. Absolute value makes it 4, minus 7 is a negative 3. 5 times 2 is 10, minus 12 is a negative 2. Absolute value makes it positive 2, minus 7 is a negative 5. 2 times 6 is 12, minus 12 is 0. So minus 7 is a negative 7. And then it should go back in the other direction. So now we plug in 7. 2 times 7 is 14, minus 12 is 2. Minus 7 is negative 5. 2 times 8 is 16, minus 12 is 4. Minus 7 is a negative 3. And last point, 9. 2 times 9 is 18, minus 12 is 6. Minus 7 is a negative 1. So all these negative values that we can plug in over here. So 3, negative 1 is our first point. Then 4, negative 3, whoops, down here. Sorry, ignore that point. 5, negative 5. Notice this one's steeper too. That's again because of the 2. 6, negative 7. That's our turning point. And then we should be going back in the other direction. 7, negative 5. 8, negative 3. And this one I'm going to go off the grid for just a moment. 9, negative 1, so we just go a little farther over here. All right, so those are our points. Last thing, we've got greater than or equal to. So greater than or equal to means it's a solid line. And then greater than means we shade above. So from where the vertex is, if you go up above that, you end up kind of inside that shape. So it looks like this. All right, so that's what the inequalities look like.